very happy to be here to moderate this session about EV manufacturing to meet the global requirements. Just to go back to the intention with which India has initiated electric mobility way back in 2013 when our erstwhile Prime Minister Manmohan Singh launched the policy report, followed by RMI report in 2016, which was to great extent adopted by Niti Aayog, where they initially talked about EV penetration, switching over to EVs by 2030, and then it was moderated to 30% penetration in 2030. The main reason why the government wanted to adopt electrification of mobility was basically to achieve energy security. Our imports of crude is exponentially increasing every year because of the increase in automobiles every year. So adopting EVs to a great extent would reduce the imports, though we may be initially importing the raw material required for making cells, etc. But after some time, if you are able to efficiently recycle the battery materials, maybe we would reach a point where our import of these raw materials for cells may come down year after year. Then the other thing was related to the pollution, especially in cities like Delhi, where every winter we have very bad air quality air which we are breathing, and about 20% of these emissions are attributed to automobiles. So with EVs, there is no tailpipe emissions, though there is, basically some emissions because we are still using thermal stations for generating electricity. So with more and more electricity generation from solar and other non-fossil fuel electricity generation, we would be improving the emissions from the electricity what we are going to use for charging the batteries. So right now there are a lot of manufacturers making all electric vehicles in all segments, starting with two-wheeler, three-wheeler, passenger cars, light commercial vehicles, buses. And most of the aggregates required for electric vehicles are still being imported, and most of them coming from China. So if we have to achieve good penetration of electric vehicles, the basic cost of electric vehicles has to come down to a level which would be at par with what we are paying for IC vehicles right now. But with most of the things getting imported, right now the battery costs are very, very high, and as a result, in spite of the government subsidy or support for various categories of electric vehicles which are being sold in the industry, we are still, the initial acquisition price of most of the vehicles is very high. Though if you do the real TCO analysis, the extra price paid for electric vehicles will get compensated by lower running costs in a couple of years. But general sentiment of customers to pay more for getting any vehicles is difficult. And also, if EVs have to be adopted in mass scale, the price affordability is one of the very important factors. Having said that, we have with us in this panel two experts who from different backgrounds. So we'll try to understand from them what is required to actually boost the manufacturing of electric vehicles in India. So I will first request Mr. Sivaramakirushnan, who has long experience in working on manufacturing process for automobiles. He is from Stellantis India. I will request him to briefly explain the complexities in automobile manufacturing and superimpose electric vehicle manufacturing to make it clear how complicated EV manufacturing would be compared to IC vehicles. Over to you.
Thank you, sir. Myself, Sivaramakirushnan, let me start with my introduction. I have total 30 years of experience. My first 8 years with Ashok Leyland, a commercial vehicle manufacturer, and next 16 years with Ford Motor Company, and then the last 5.5 years with Stellantis. All in manufacturing, and predominantly I'm in manufacturing engineering. Until 2020, I'm fully exposed with ICE vehicle manufacturing. And then starting with 2020, I had a good exposure on EV vehicle manufacturing, and that's when the EV vehicle manufacturing exposure got started with me. I would like to give you a fair comparison in terms of what is all about ICE, internal combustion engine, and how different is the EV manufacturing, and what different we do from automotive standpoint in terms of make this manufacturing cost effective, at the same time it is robust enough. If you, on a larger scale, if you look at the ICE is well matured, internal combustion engine vehicles are well matured, the process is well established, and you can understand the scale in which it has grown in India. The EV penetration has started way back 5 years back, and again even before. But again, the good momentum has started from the last 5 years, and now it has got a lot of significance. I just want to share with you some of the significant differences or some of the vital important items which we all need to know so that you can understand the complexity involved in the manufacturing of electric vehicles. Let me start with the battery pack. The battery pack as such, you know, it is a one which delivers high voltage. Basically, it charges so much of energy in a smaller space. What is significant from manufacturing standpoint? If you look at the manufacturing environment that is needed for the battery pack, the relative humidity should be less than 10%. That's very, very important, because if you have a higher relative humidity, then there will be an oxidation happening on the terminals, which is not good for the battery performance. If you look at the individual cells, it has to be sorted to make sure that it has got a required IR. It should be well within 2%, which means the sorting of the batteries before it is getting assembled is critical. If you look at the capacity, again, it needs a proper sorting, and any variation beyond 2%, it will have a detrimental effect on the battery performance. And again, it's not just the sorting of batteries. Again, the way we connect the bus bars are extra critical. The positioning of the bus bar should be well within 200 microns. And if at all, if there is a torquing involved, the torquing component the variance of the torque should not exceed 2.5%. Again, with all this complexity, all this criticality from technical standpoint, it is important that how we convert these product characteristics into process characteristics and ensure that we achieve consistency in the manufacturing. So how do we achieve? Example, if you want to have a good torque capability, you need to go for a DC nut-runners. If you need to have a good consistency in the welding capability or positional accuracy of the bus bars, you need to go for a robotic application, including the robotic handling. The whole ecosystem should be well thought about to make sure that the consistency is the outcome. What if we don't maintain this? The consequences, any positional change on the bus bar, it will lead to short circuit in the system, and it will even lead to a thermal event. So again, from the motor standpoint, motor is something unique component, which is, it has to deliver a low instantaneous torque. For example, if you look at the entry-level cars, it has got the torque of 110 Newton meter, wherein which an equivalent ICE vehicle has got the entry torque of 69 Newton meters. So you can see the extent of torque the motor has to produce. At the same time, if you look at the RPM in which it rotates in the range of 15,000 to 20,000 RPM, which is quite significant. Similarly, if you look at the power to weight ratio, the EV vehicle, the power to weight ratio is 4 to 7 kilowatt per kg of the electric powertrain, wherein which for the equivalent ICE, if you look at, it delivers relatively lesser power to weight ratio, which is close to 1.5 to 2.7 kilowatt per kg. So what it implies, the manufacturing of electric motors carries a lot of significance. When the rotor needs to spin at the speed of 15,000 RPM, you can understand how precision it has to be. And if it has to have a good power to weight ratio, you can understand how critical it is important that every component that is involved in the motor manufacturing has to be significant. Likewise, I can talk about the complete whole ecosystem involved in the electric vehicles, but again, for want of time, I just want to give you these two examples to make you understand how critical is in terms of the EV manufacturing. And again, having said that it is so critical, it is important that how we scale it, how we make it work. That's important. I'm not asking about asking you to go and start a dark factory, like put millions of dollars and like what we have in China. No, I'm not talking about that. So we need to have a discipline in terms of assembly process. We need to have a consistent outcome, which means like we can have the good traceability system being implemented. We can have a simple automation being implemented so that you can place the bus bars intact. You can have the status wound properly with using a simple automotive system involving IoTs. So these are all some of the items which, as a manufacturer, we need to think to ensure that the consistency in the outcome is well established. Before I close, I just want to add one more point. If you look at the OEMs in India, the OEMs in India are getting matured. Four-wheeler, like starting with two-wheelers, three-wheelers, four-wheelers, it's getting well matured. But the real challenge is how the Tier 2 and Tier 3 are well established. So it is not about the Tier 1 is well established and then they have a consistency in the outcome. It is also equally important that Tier 2 and Tier 3, how they are delivering the equivalent consistency so that the whole ecosystem works in a consistent way. So which means the Tier 1 has got lot of responsibility to make sure that the Tier 2 and Tier 3, their component suppliers, are equally equipped to make sure that the right manufacturing process is implemented, a good traceability is implemented, so that it supports the Tier 1 vision of getting a consistent vehicle and ensure that a trouble-free vehicle is manufactured. Thank you.
Yeah, thank you, Mr. Sivaramakirushnan. I just have a question. Can you throw some light about different manufacturers adopting IC vehicles and converting them to a EV? Vis-a-vis some manufacturers going for a totally new platforms to cater for EV requirements. Do you think both will survive and both will be equally efficient, or what is your opinion on this?
Sir, this is a very valid question. In the whole, the new technology, we talk about circular economy. Again, I will answer your question in relation to circular economy. What is circular economy? So we say that ICE vehicles or the internal combustion vehicles are polluting and we need to switch to EV. Again, there is also a larger question that whether EVs also can equally pollute. The batteries can also pollute. But again, the circular economy is something coming in a big way, which helps in terms of making sure that every component that is prevalent in the EV vehicle can be reused. Say, the battery recycling. The battery is getting crushed, and again, it's getting recycled through the pyrolysis process, and again, there are multiple processes that exist with which the whole system is getting recycled. It's not just the recycling of EV vehicle we should consider. We should also consider about the conversion of the ICE vehicle is also sort of circular economy. With all the fuel price that is rising, it is equally important that, there is a strong ecosystem should be equally developed to ensure that there is a strong provision for conversion of the EV vehicles, ICE vehicles into EV vehicles. There are some startups have evolved in a very big way in terms of converting two-wheelers, three-wheelers, even four-wheelers for that matter. And again, the government is also equally promoting in terms of authorizing such, the players to flourish in the market, give a strong support to make sure that they are consistent. But only one catch is the EV system as such, there is a lot of myth about, thermal runaway and so on. So the startups and the people engaged in the vehicle conversion, basically the ICE to EV conversion, should ensure that the equivalent manufacturing process are being adapted as compared to a OE that produces an EV vehicle, so that the risk of thermal runaway can be completely avoided, with which a strong ecosystem can be built up. And again, with all the rising fuel prices, this will be a big boon for people of India, because, India is filled with a lot of different sections of people. And again, the EV conversion, if we can do it at a scale in which people can adapt, it will be a big benefit to all of us.
One more question I have. Most of the electric two-wheeler, three-wheeler manufacturer are all startups. Do you think all of them will be able to scale up to bigger numbers than what they are making now? Because auto industry, as you know, auto manufacturing is a mass production system. So will they be able to scale up their manufacturing and compete with the legacy players who would get into electric vehicle manufacturing?
Sir, this is a very good question. Every OEM that exists in India, they are now they are switching, or they are doing a parallel processing to make sure that they are capable of producing EV vehicles. And again, name any in India, they are into EV manufacturing. So I don't have any doubt in terms of the existing players getting established into EV, because obviously at some point in time, they have to migrate. And again, the classic example is China. The other question is how the startup can evolve and how they can sustain. Again, my question going back to my first conversation about the manufacturing and manufacturing a consistent product. Any startup who is capable of giving a consistent product, when I say consistent product, a product which can meet the customer's end requirement without any flaws, putting a lot of PFMAs and DFMAs into the product to make sure that the product is not flawed, it delivers the right outcome. And if the startups can create an ecosystem surrounding these items, then obviously there is no doubt any startup who has got this right mindset will flourish like anything.
Thank you. That is very encouraging inputs you have given. We also have Mr. Jitendra Patil, who was head of EV cell in Maharashtra. So I request him to give talk about how EVs in Maharashtra have been promoted by their government initiatives and policies, and also how they are encouraging EV manufacturing in Maharashtra.
Thank you, Mr. Rao. I'm Jitendra Patil. I'm heading the EV sale of Maharashtra. Maharashtra, to be specific, has been one of the leading states as Tamil Nadu in promoting EV transition, promoting EV manufacturing, and also ensuring that EVs are being used and not only purchased. To be to give you an idea, basically, the state government of Maharashtra, because EV ecosystem depends upon the support from the central government and the state government, uh, be it about import and then coming up with an ecosystem wherein you have an ecosystem wherein the manufacturing is promoted, the use of the vehicle is promoted, and the support systems that are required for running this whole ecosystem. And one of the major aspect is power and availability of the power. So it's basically a five departments which are involved into it, apart from the users and the manufacturers and the MSMEs. The government of Maharashtra has come up with an EV policy 2025. We had our first policy from 2020 to 2025, wherein the use of the vehicle was promoted, that people should be induced to purchase these vehicles. Because as it is, we had to break the ice in terms of use of the vehicles. The reliability of the EV was to be driven home amongst the users, and that's the vehicle owners. So that was one of the fundamental challenges which we had to face. And this we overcame by promoting, we have 100% tax exemption for EV vehicles way back from 2019, or even before the policy came into picture. Apart from that, developing the ecosystems of vehicle manufacturing, battery manufacturing, and MSME manufacturing. We have two major hubs in Maharashtra, where one in Pune and other in Chhatrapati Sambhajinagar, where the existing ICE industry to ancillary human resources now has been, they have been channelized, or they have been encouraged to venture into EV component manufacturing. And apart from that, it's not only about giving basic demand incentives for the vehicles which have been purchased. We have one for the FAME. Through FAME, we used to get the incentives for purchase of an EV that was given by the central government. But then over and above, Maharashtra government also gave a basic demand incentives for purchase of two-wheeler EVs, four-wheeler EVs, goods vehicles. And this was only to drive home the message that people should buy it, and the government is behind it, and government is on serious on this transition. There are a lot of problems in terms of coming up with the ecosystem as such. One of the biggest problem we have identified is how do we have the charge point operators in place? Because purchasing a vehicle, the basic motive of a person is convenience of drive, convenience from going one place to other. And if we are making the user experience better, so we have to have these charge point stations. So in order to promote the use of the vehicle, we not only gave the demand incentives, but we also have ensured, we have declared few corridors, like Mumbai-Pune corridors is a EV corridor, Mumbai-Nagpur corridor is a EV corridor. And then we have exempted tolls on this EV vehicles. We gave 100% toll exemption on this EV vehicles. So now what has happened? People have started using EVs for commute from Pune to Mumbai. Obviously, when people have started to use EVs from Pune to Mumbai and back home, the charging infrastructure got the demand. And now, since the charging infrastructure got the demand, the charge point operator volunteered to set up the stations over there. And one of the most profitable charge point center is on the Mumbai-Pune Expressway. So this is how I think gradually we have to come up and develop an ecosystem. And in terms of MSMEs, we are promoting MSMEs through industry department. And as rightly pointed, the circular economy that is very important for this EV manufacturing and recirculation of the EV parts. So we have a battery recirculation policy which is also coming up. there are 5 departments basically to come up with transport, industry, power, environment, and the urban development, which provides for the infrastructure. Because one of the basic issues which we found in charging infrastructure is the land, which is very important. The capex involved in the land is very prohibitive. And even if you have a available land, we need the power connections for that capacity. So it's this is how basically we have an cell which is headed by the additional chief secretary transport, who coordinates between various departments. We have interactions with the stakeholders and the issues are taken up, sir.
Thank you, Mr. Jitendra. We have amongst our audience Mr. Vijayanand, who is ex-CEO of Amar Raja, and he had personally steered the setting up of the cell manufacturing unit in Hyderabad. So I would request him to share his experience in setting up cell manufacturing facility and also highlight what are the complicated manufacturing processes involved in cell manufacturing.
Thank you, sir. The conversation has been extremely interesting, and thank you for looping me into this, because we heard in the plenary session that almost for all practical purposes, the IC engine is getting replaced by battery, and hence when we talk about EVs, battery become a very integral part, making up almost 40-45% of the final vehicle price. The conversation around e-mobility seriously started way back in 2016, which where you refer to the RMI report, and then Niti Aayog adopted it. Then there was this, hugely popular MOVE conference that happened from transition to electric mobility. I was part of many such deliberations, and there were 6 specific challenges that were identified at that point of time, and they used to be the consistent themes in the conversations about what's the real challenge for localizing or creating a domestic value chain for EV, and I will speak more about the powertrain and battery as a component. One of the things was demand. Was there demand visibility? Back in 2016-17, there was a lot of discussion about how the fuel mix will change, powertrain, stipulations or policy will be moving. How much is the EV demand? There was a lot of uncertainty about that. The next one is about the policy consistency. The government, which way it is, BS6, biofuels, hydrogen, EV, hybrid, it wasn't very clear. The third element is about the technology direction. What technology should India adopt? Even if you were to say EV, what technology should India adopt? And those days, NMC cell was seen as probably better than LFP cell. And there were a lot of people arguing that LFP is not going to be successful. LTO is another chemistry that was being talked about. So what's the technology choice India should go for? And the fourth one is about the capital risk. At least in the battery industry, typically in automotive component industry, if you are adding significant value on the shop floor, the thumb rule is that for every dollar that you invest, you will be able to make at least $2.5 revenue as an organization. And hence the margin matrix, everything is calculated based on those ratios. But when it comes to batteries, with the kind of price that was going down and the capex intensity of the industry, for every dollar you put, you only get $1 revenue. So the gestation period for the money that you're putting in and the return on that used to take longer time. So there is a capital risk and a patient capital that's required. That's the fourth item. The fifth was supply chain. While we can make batteries in India, where are the materials going to come from? And, will the mineral availability a big challenge for India depending upon whatever technology, chemistry that we adopt? And the last one is about the skill availability. Are there enough people? India has done exceedingly well over the last 30 years to build the automotive manufacturing ecosystem. While we may be around 14-15% on the GDP contribution by manufacturing, half of it comes from automotive industry. That's a level of strength that India has built over 25-30 years. And I know some of my industry colleagues from ACMA and SIAM used to say, We have now come to third position, second position, commercial vehicles, passenger vehicles, two-wheelers. We are in the top 3-4 positions globally. Now, if you were to adopt electric vehicle, are you going to go back in the queue and stand in the end and then, make our way again all the way? And hence, where is the skill going to be? Where is the talent going to be? Where is the research capability going to be? From there, sir, now we are 10 years down the line. I think the demand visibility is slightly better. I wouldn't say, we can do a crystal ball glazing with absolute clarity, but definitely a lot better than what we could do 10 years ago. The policy is relatively consistent. There's a lot of initiatives that government has said in terms of their intent to support this transition, in terms of financial support, in terms of directional support. And the choice of technology is also becoming reasonably better than what it was 10 years ago. LFP is becoming, the most sought after chemistry as far as batteries are concerned. And then moving into sodium ion and solid state and all of that is the future that we are talking about. And capital risk is understood. I can't say that, it is fully resolved. Are the lenders queuing up to support large-scale investments in the battery space? Not yet. But at least the risk factors are relatively understood. Two factors that we haven't yet fully resolved is about the supply chain and the talent availability. Talent is a within problem. It's a problem for the company to solve. It's a problem for the country to solve. I don't think anybody else is going to come in our way to when we solve. But supply chain is becoming a global challenge. And we have seen a lot of dynamics evolving over the last decade as we were moving forward to look at Kabil was formed to access minerals. A lot of discussion happened around technological partnerships, but geopolitical scenario that's evolving around us is not making it very predictable and very easy. I think that would continue to be something that, bothers people who are deeply engrossed with that. And finally, I believe that India has the right to win this game, considering what we could do in specialty chemicals and the pharmacy industry, automotive component industry, automotive vehicle industry. We have proven that we can get to global scale. We can meet the domestic demand absolutely clearly. More than 80-90% of domestic demand can be met by local manufacturing. We can also become a net exporter when it comes to it. I think that's the opportunity we have.
Mr. Vijayan, that's a very, very encouraging feedback from you about to say that India would be successful. But I have one more connected question. China has already reached stabilization and perfection of the process for making cells. And also they have manufacturing set up for very, very big volumes. India is just starting manufacturing of cells now. And in your opinion, how much time will it take to maybe catch up or at least reach those volumes, especially with reference to the pricing of these cells? Because to my mind, when the cell manufacturing starts in India, the cells are going to be extremely costly compared to what price we are paying for import from China. So when will this parity happen?
Yeah, there are two angles to this question. One is the capability building to compete with China from a capability perspective. The second angle is commercial competitiveness. China took 20 years to arrive at where they are today, and their journey hasn't stopped. They're still continuing. I don't think India needs to spend next 20 years to reach where China is today. We can definitely accelerate and filter through what is more relevant for future. We don't have to do a lot of iterative experiments like China had to go through that. And I'm not by any stretch of imagination, imagining that India can produce a competitive cell 3 years from now and then landed cost of Chinese cell and the cell made in India would be comparable or even competitive. Some level of support is required. I think there are three elements that we need to look at. What is that government can chip in terms of subsidy? What is that customers are willing to provide what I call as the security premium, material security premium. When you want to localize the cell, what do you want to localize it for? If it is only for price, please don't waste your time. Are you looking at supply security? And hence, what premium are you willing to pay for that? And then investors, those who are setting up the plants, will have to have that patient capital. They need to contribute to bridge this cost gap for some more years before it becomes workable. Is there a number I have in my mind as to how many years before India become self-sufficient and competitive compared to China? I think the journey ahead of us will be, in the most optimistic scenario, 5 to 7 years, and perhaps more realistic scenario, 7 to 10 years, before we can say they're producing. Now, in this process, I also know that the technology is not going to be static. So how are we going to adopt technologies that are more relevant for India and markets like India outside? I think India should look beyond India as a market. The people like us who are investing into that cannot look at India as the only market. So what are the global markets that we can access and hence scale up beyond the domestic demand? So I think capability-wise, I am confident we will be able to build. Competitiveness-wise, it's a little time factor that will make it happen.
Thank you. Thanks for your inputs, and it's very, very interesting to know that we will some point of time match China, at least in process and supplying manufacturing cells. Now, I have one question to Mr. Sivaramakrishnan. We have talked about how the EV manufacturing is more complicated compared to IC vehicles. I just want to tell us what else needs to be do to supply to global markets. EVs for India or EVs for global markets. What things needs to be done differently, and whether we will be able to be competitive when we are supplying to overseas countries.
Yeah. First, I will try to talk about the phase shift that has happened right now in the automotive evolution sector, and then talk about how do we scale it from India to the rest of the world. Okay. Way back, when I moved from a commercial vehicle manufacturing to car manufacturing, that's when, 2004, where, from the inception till the product is out to the market, it was taking close to around 36 months to, no, not even 36, 48 months to even 60 months, which means 4 years to 5 years is this lead time that is needed for a complete car to be evolved right from, the inception to the vehicle on the road, which includes both platform and top hat changes. Today, the scenario has completely changed. The 5 years lead time has come down, or 60 months lead time has come down to 24 months to 36 months. How this is possible? Yes, it's possible. How? Right now, we talk about modular architecture. So what is modular architecture? We have a common platform, and that platform being utilized by multiple OEMs, wherein which they build the top hat over about the platform so that, the scaling becomes much easier. When you have a ready-made platform ready to use, adding a top hat, it's again another 18 months to 24 months lead time factor. So now there are a lot of companies joining together to create a common platform, and then they try to customize the top hat so that they can, sell the vehicle in the way they want. That's what is getting evolved. It's not just specific to four-wheeler. Even two-wheelers are following the modular architecture. Even three-wheelers are following the modular architecture, and then the four-wheelers is not an exception. Coming to, on the modular architecture, it's not just the platform. They are also talking about, the conventional EV vehicles has got hundreds of modules integrated through a common ECU through which the whole ecosystem start functioning. But now the hundreds of modules, or even the low-end vehicle, it has got at least 15 to 20 modules, is getting converted or downsized to 6 to 7 modules, with which with the minimalistic intervention, the systems interacts, and then it is having a flawless communication. This is really helping in terms of reducing the overall lead time in terms of from the point of inception to the market, so that the customer gets a product ready to use. Again, going back to the question on how do we scale up to the rest of the world. One important point is, 3 years back when I was in China for a different exploration visit, I was quite impressed to see that how China is overcoming these challenges. For example, if you look at the batteries that is existing in the cars in India, it has got a bottom, it has got the modules inside or the battery module inside, and then there's a top cover over and above that. And then the complete battery, we deck it to the underbody so that it forms the part of the vehicle. China, what they are doing different is, they have eliminated the battery top cover. Only the battery bottom cover and the modules exist, and the vehicle chassis itself acts as a top cover, so that they were able to bring down the cost, one. Second, the space needed, like with the same area, they are able to pack more number of batteries, with which they are able to improve the overall mileage. So these are some of the innovations that is coming up. And again, my point is, when we want to scale up, it is important that we don't start from zero. We should not get into a situation where we will have everything indigenous, we will start everything from zero. We need to start from certain levels. It's important that we try to create some sort of joint ventures. We try to learn from our partners, and then from there, with a lot of talents that exist in India, we can easily scale up. There are many examples that exist. Two-wheelers, three-wheelers, four-wheelers, they have come up in a very big way. Even certain vehicles that is produced in India, manufactured in India, is comparable to the rest of the world, and the world is looking at India in a very big way, because they could not imagine that we could have such a great vehicles on the road, particularly EV. And again, these are all from the traditional Indian manufacturers. So it's important that we have a right mindset, and with the mindset, blending the evolution in the technology and the innovation that exists in India, it can take automotive world to the next level. That's my point.
Thank you, Sivaramakirushnan. With this positive note from you, we want to close the panel discussion. We can take 2 questions from the audience. Anybody? Yeah.
Sound check. We'll open the house for questions, requesting the audience to kindly keep the question a little short as we're running short of time. Over to you, sir.
Good morning, sir. I'm Vinkamada Chakravarti, ex-Indian Air Force officer. I've just taken a retirement and getting into this business. My point is, like, I've understood the whole setup, what you have been talking, and it's actually quite enterprising and hopeful. But one question is regarding the supply chain, which sir had mentioned. The core, that's the foundation for this whole building. We are actually building the whole building well, but the foundation, I feel, do we have any actual concrete plan regarding this? Like, okay, China has actually captured most of the lithium resources, I was told. Are there any alternate resources which we are getting? Are there any other countries which we are approaching? I would like to just know on that aspect, sir.
China has captured most of the known lithium resources. I don't think we have really explored the unknown part of the lithium resources. The reason I'm saying is, globally, if we today consider that the battery capacity is X, all market forecasts say it can go up to 3x to 4x in the next 10 years, which means we need so much more material to come from. And when X becomes 4x, China is today 0.7x in the global capacities. Assuming that they will maintain that 70% hold on at 4x level, doesn't appear to be very practical if you look at many other industries that have scaled up. So my belief is there is probably a lot more work to be done to explore lithium resources and also look at recycling. Today, not many batteries are coming back into the supply chain in recycling because end of life is still not being met outside China. India itself is expecting a lot of batteries to come back into recycling loop in 10 years from now, 7 years from now. So a lot of growth will happen based on recycled material. Incremental virgin material is also required, but there is a lot more exploration required.
Thank you, sir.
If there are no more questions, I would like to thank this. Yeah, please.
San. Looks like we just have one question there. We'll take that question before we wrap.
Good afternoon. My name is Rahul Magdum. I am from SPR Auto Interior Lighting Solutions, Pune. My question is, in EV ecosystem, most important thing is dealer and customer. So now on social media we see lot of noise where the customers issues not solved in time, and because of that the bad mouth publicity will resist the new buyers. So is there any, we are more focused on the manufacturing. We use lean tools, TPM tools, TQM tools to bring our manufacturing to standard world-class level. But what about dealers level? Is there any plan? Second thing, in government level, is there any framework which will support customers for these kind of issues? Thank you.
Thank you.
Should I take it? Thank you for the query that you have raised. Obviously, since you are from Pune, I also come from Pune. There has been a lot of social media hype as to what kind of services have been offered. I think the government has one forum called Consumer Forum, where these cases have been launched. But specific to electric vehicle grievances that we have, I think we can come up with a portal or a system wherein these complaints can be entertained and addressed to. It's a good suggestion, sir, basically, and I think this should be taken up everywhere. We have a EV cell in Maharashtra government. I think we can take this as an aspect where customers can give their complaints, and then we can see through arbitration whether it can be resolved, talking with the company and the service provider. Thank you.
Adding to what Sir has said, I just want to add few of my experiences. Way back in 2022, when we first started manufacturing the EV vehicles, what we first concentrated is on the training of the ecosystem. So when I say training of the ecosystem, when the battery is being received in the plant, we want a proper handling to happen, and we clearly train the resources who is involved in the battery handling. And second, the people involved in the HV circuit, we trained them with the expert from outside. Even we collaborated with the college outside, and then we got our resources trained. It's not just the manufacturing ecosystem is getting trained. It is equally important that the dealers and the corresponding people who are handling the vehicle is also equally trained. We put a lot of effort in terms of training all the dealer people who is involved in the electric vehicle servicing, and that has helped in terms of navigating the issue of the complaints from the people that we don't have adequate people to service and so on. So which means a well-planned training and imparting the proper training to the individuals involved in the whole ecosystem is equally important. What we see as a biggest challenge today is, the startups, they focus more on, developing their own infrastructure, but again, they also need to spend enough time and resource and money in training the dealer principals so that they are well prepared to take up any challenges. I see there is a gap, but again, I think with time, it should improve.
Thank you. I hope the India's dream of leading EV manufacturing for the world will come true very soon. Thank you.